the next speed sponsor from GWI, or Global Web Index, and we have Dionysis Tsoumas, whom I met actually in the conference after a lot of years. So hello, Dionysis. So he's the head of DevOps, and he's going to talk about full throttle using the Grafana stack. So please welcome Dionysis. And,
welcome, Dionysis.
Thanks a lot to GWI.
Hello, everyone. My name is Dionysis Tsoumas. I'm head of DevOps at GWI, and I'm here today to present you our exciting journey at GWI with the whole Grafana monitoring stack. Actually, this is a topic I'm very passionate about. Anyway, yeah. That's a topic I'm very passionate about. It's a great example about how an open source stack with a bold vision can have such a big impact on an engineering team. But before we talk about Grafana, let's take a step back. So GWI, until a year ago, they were using Stackdriver. If you're not familiar with Stackdriver, that's fine. Stackdriver is a GCP's monitoring solution. And in the beginning, it has worked very well for us for a few years. People were not very excited. But anyway, it was fine. In fact, it allowed us to scale because out of the box, we had monitoring for most of our GCP resources. And back then, we had a very small DevOps team. So, working something out of the box, it was great. But it was a bit clunky, a bit slow, the UI a bit questionable. And even back then, we knew that probably it wouldn't scale very well from us. It can be kind of expensive. But anyway, none of these reasons is why we decided to move away from Stackdriver into Grafana. The reason is that we're using Terraform, and Terraform is infrastructure as code. It's amazing. It allows us to scale. But back then, we took a bad decision. So for us, infrastructure is GCP, and everything is through Terraform. Stackdriver is GCP, so we took the decision to have all the metrics and alerts in Terraform. And I'm not sure if you have played around with Stackdriver, but it can have some resources like that. So 40 lines of code, this is a very good example, 40 lines of code for just a simple uptime check. So imagine like the poor engineer that goes and tries to debug this kind of stuff. But anyway, we're not here to make fun of Stackdriver. This is the main reason why we decided to move away. And the idea was we wanted to free our engineers for spending time in Terraform and move the same resources to something that they were more familiar with, like Helm charts. So of course, then we decided to integrate with Prometheus. In fact, we went all in. All right, so we have used Thanos to scale all our Prometheus clusters and all the nice little services that were coming along with the Prometheus operators, stuff like Alert Manager and Black Box Exporter. But we're not here to talk about Prometheus either. All right, things start getting interesting when we wanted to visualize our metrics. And this is where we use good old Grafana. So again, at that point, we're in a state where people start migrating slowly their metrics and alerts from Stackdriver to metrics and Prometheus alerts. And what's next? Then we decided to integrate with distributed tracing. And now every big player out there, like Sentry, New Relic, Datadog, even GCP itself, it has its own managed distributed tracing solution. At that point, we were already devoted to the Grafana stack. That's why we decided to go with Tempo. And Tempo, it's a very easy to use open source distributed tracing backend. It only uses a bucket object in order to operate, and it integrates very well with both Prometheus and Grafana, and it's working out of the box with your favorite distributed tracing protocols like Jaeger and OpenTelemetry. So let's have a quick look on how Tempo looks like. So here we have a Grafana dashboard. We have a trace ID. We're going to talk about traces IDs in a bit. So we just get this trace ID from somewhere, we query, and then we see the whole journey of our trace. In this particular example, the request takes 3 seconds, so we need straight away, we can dive deep and see where it spends most of its time. Here, it's obvious. In that request, it spent 2 seconds. And then we can see the attributes of all the requests, and then we can go back and find the issue and try to fix it. Tempo, it has some other very nice features. One of it is like node graph. So with node graph, it gives you a high-level way to visualize your journey of your request. So in our case, this is a complex request, but we can see straight away that it gives us a very good idea about all the hops of our requests. And sometimes this is very nice. Distributed tracing, it's amazing. It can let you know where you spend most of your time, especially if your requests are slow or especially if you have many microservices. But it has some downsides. The most obvious downside, what we've seen, is that it needs a trace ID. And you can guess where you get those trace ID from. It's from logs. And of course, we're using GCP for logging as well, which means engineers, they had to jump on GCP, find the logs, get the ID from there, and then jump into Grafana, paste the ID, and then continue with the research, which is not, it's not very scalable, is it? So this is where Loki comes into place. Loki, it's again from Grafana, and it's a horizontal scaling, highly available log aggregation system that it's based on Prometheus. Well, it doesn't use Prometheus, but anyway, you know what I mean. So Loki is also very cost-effective, and the reason it makes this possible is that because it doesn't cache all the content of the log, but instead it caches a set of labels on each stream. Quick video of how Loki looks like. So it's similar. We have Grafana, and from the data source, we just want to have a look, we want to find the logs of an application. Our application is called Gateway, and we don't care about any kind of logs, we only care about errors. Now we use the builder, but we can very easily also write the query itself. So our application has a couple of errors here, which is fine. And it's nothing very, very fancy here, nothing very new. We can see the logs and see all the attributes. But what's very interesting is that we can see the trace ID over there, and then it has a button next to the trace ID. So very easily we can jump on the same window and see the whole trace of this request based on this log. So things start getting very, very, very powerful. I'm not going to spend too much time on that, but the idea is that we keep adding on technologies that we care and we are familiar with. So right now we have Prometheus, Tempo, and Loki. And if we group all together, we can have some very creative dashboards. This is an example of one. It combines data, observability metrics from Prometheus, memory, resources, out-of-memory events for your pods, and then you can also view the amount of your logs and the logs themselves, and very easily you can jump from a single log to the tracing, to debug easily when you have issues. But we can do better than that, okay? And in fact, we can do much better than that. So the next thing we will introduce, it's called exemplars. And it's difficult to explain what exemplars is. It's something that you need to visualize it, but let's see what we have done until now. So we have metrics. And metrics give you a very good high-level idea about your system. And then you have traces. And traces, they're fine-grained information about a single request. So exemplars are here to link those two things together. This is a definition. It was a bit difficult for me to memorize. So an exemplar is a specific trace that is representative of measurement taken in a single time interval. Exemplars, they are traces. And if you wanted me to explain what it does, exemplars, they try to link specific requests, specific traces with observability data. And we'll see now in a bit how important this is. Now, let's pause for a bit to see what we have here. This is a new dashboard. And it showcases the latency of a service. Let's see what exemplars will do. So exemplars will try to let us know what's happening in our system when the system is slow. If a request is slow, what's happening under the hood? And it's a bit abstract until now, but for us, in this specific example, exemplars are those green dots that you see in the dashboards. Okay, so we have these green dots, and then we click, and then we have all the information about the trace, about the request itself, with the trace ID as well, and then we can click, and now we know that tempo is there, so we can see the distributed tracing, and based on this distributed tracing, we can jump in the log straight away with Loki. So without exemplars, we didn't have an easy way to say, OK, we have latency. We know that some requests are slow. How are we going to find those requests? How can we find the traces of the specific requests? And this is where exemplars are coming from. And they're supported with Prometheus for now. And if you have everything in place, it's very easy to be implemented. I think in our team, it took less than a sprint to have a POC up and running. So if you want to get something out of this small short presentation, it's this graph. It's from last year. This is why you see Grafana 7 and not Grafana 9. But it gives us a high-level overview about how seamlessly we can jump from metrics to logs and traces. And we don't care only that this thing is possible now in the open source community on a very cost-effective way, but the cost-effective is key here because it's cheap to run this on a cloud scale in your own infrastructure. And this is only the beginning, all right? So I can't even wait to see what the teams can work and implement in the next couple of years. Just in time. Thank you for your time. If you have questions, either here or if you don't have time, I will be outside until probably tomorrow, but definitely today. So looking forward to talking to you. Thank you.
Thank you.